Okay, well, here we go, and here's another example of using derivatives and helping find the slopes of curves at any given point. So slopes of curves. Once again, the slope of a curve is a derivative. So what we're here to do is we want to take this function and we're going to find the slope of the curve at x equals 1. Now, first off, whenever I'm given a problem like this, I like to graph it, and this is the absolute value of x minus 2. Now, hopefully you're familiar with these. This is a basic function. It's an absolute function, absolute value function that's been shifted over to the right 2. Okay, and so we're going to graph that, and we have this right here. Now, in doing so, we're realizing, okay, we're trying to figure out what the slope of the curve at 1 is. Now, at 1, we see that the absolute value function actually are two lines. And in this, we have these two lines. And so to find the slope of this curve, essentially, we're trying to find the slope of this line right here. And the line is constant. So we're going to find the slope by actually finding the slope of this straight line. So we're going to take 2 points. The 2 points we're going to use, I'm going to use f of 1, and I'm going to take f of 0. I'm going to take 1 minus 0 and find that slope, okay, to find the slope of this curve. So if I take these 2 points, that slope is going to equal the same slope. It just happens to equal the same slope of every point on this graph. So to do that, we're going to take 1, plug it in there, and we should get 1, minus 0, and we're going to have 2, over 1 minus 0, which is 1, and that's going to equals negative 1. And that makes sense because we see that this is a decreasing slope. So the slope of this curve, so in this instance, f prime of 1 happens to equal negative 1. We could do the same thing, and I bet we get a very similar answer, if we wanted to look at the other side. And so if you wanted to just do an extension of this problem, we could go to the other side and find out what the slope of the curve at 3 is, at 3. All right, so if we look right here, we say, okay, what's the slope of the curve at 3? All right, well, find f prime of 3. Well, once again, realize that that is the same, so we could take these two different values, so we can find f of 4 minus that f of 3, 4 minus 3. F of 4, plug in there, would be 2, minus, plug in the 3, we can have 1, over 1. Once again, we get a single answer of 1. So f prime of 3 equals 1. Okay, and we can see that because this line and the point right there, since it is a line, all the slopes on this interval, all right, from 0 to infinity, sorry, not 0, from 2 to infinity appear to be at the same slope, which in this case would be 1. Now, so we found both of these. I'm going to do one more extension, okay, of this, in that if I wanted to find, or if we wanted to find the slope at 2. Now, 2 right here, there's a little bit something weird there. So if I want to find the slope at 2, well, 2 is what we refer to as a corner. And if we apply the limit definition of a derivative, so if we take the limit as h approaches 0, all right, and we take it to the right, okay, and we approach, and let's just say we approach 2. So we'll go, and we'll go that way. Actually, let's go something else, I'm sorry. We'll go x approaching 2. We'll go from the right. All right, and we'll have f of x minus f of 2 minus x minus 2. Well, what that means is that we're trying to find the slope of this line, because this is a slope formula, and we're finding the slope as we approach 2 from the right. All right, what is that slope going to equal? Well, that slope we found is the same for all the other ones, like 3, so that would equal 1. However, if we take the slope and we approach 2 from the left of this, for this particular function, we realize that the slope, as we approach it from the left, we realize that this one is actually the one we would have if we plugged in 1 right there, which we got negative 1. Well, those slopes from 2 to the right and 2 to the left happen to approach 2 different values. Because they approach 2 different values, we understand, through what we know about limits, is that limits do not exist when you approach 2 different values. So actually, right here, we know that f prime of 2, we would say, does not exist. It does not exist because it approaches 2 different values. So here was a very interesting problem and about slopes of absolute values and identifying the slope of one side of that absolute value function, the other side, and also what happens when you go at the corner. And actually this is what we call it, a corner. So whenever there's a corner of a function, that derivative or that slope does not exist. All right? Well, good luck with the rest of the problems, and talk to you later.